Hi everyone. So this week we're going to take a break from looking at those volume questions and we're going to start looking at a new integration technique called integration by parts. So with this integration technique, we can then look at problems that look like this. So something like x sine of x dx, or the integral of x squared e to the x. Okay, things like this, where we have a product of two functions. Okay, so with the standard power rule or the U substitution, we can't do things like this. So we need to come up with a new technique to handle these problems. Okay, so since we're dealing with the product of two functions, we're going to come up with this technique starting with the product rule from derivatives. So remember, the product rule was something like this. If we have d by dx of f of x times g of x, then this is equal to df by dx times g. Okay, so we differentiate the first one, we leave the second one alone. Plus, we leave the first one alone and we differentiate the second one. Okay, so that's the standard product rule from derivatives. So what we're going to do now is integrate both sides. So we're going to integrate d by dx of f of x times g of x dx. And this is equal to the integral of df by dx times g dx plus the integral of f dg by dx dx. Sorry, just make that red. Dx. Okay, so I'm just integrating both sides. So now for this first term that we have here on the left-hand side, we have the integral of a derivative. So you see we've got this derivative here. Now we know from the fundamental theorem of calculus that integration and differentiation are opposites. So if you integrate a derivative, they cancel out. So these cancel out and we're left with f of x times g of x is equal to the integral of df by dx times g plus the integral of f dg by dx dx. Okay, so I'm going to do a little bit of rearranging. Okay, so one of the terms on the right-hand side, I'm going to take over to the left-hand side. Okay, it doesn't matter which one we pick, okay, because it is symmetric. Okay, so let's just pick this one to take over. So we have the integral f dg by dx dx is equal to, okay, so we took that one across, we left with the integral df by dx times g dx minus f of x times g of x. Okay, something like that. So you see that if we have something like this on the left-hand side, we have a product of f and the derivative of g. Okay, so we have f times the derivative of g, and we're trying to integrate that. On the right-hand side, we see that this derivative of g, the derivative now goes on f. So now we're differentiating we're differentiating f, and we have integrated g. So let's put that in red here. Okay, so you can see we had f times the derivative of g. Now we have the derivative of f times g. So they've swapped. Okay, and then we have this extra term minus f times g. Okay, so the idea is that if we have a problem like this, the integral of x sine x dx, like this, we have a product of two things. What we are looking for is f and g. We're looking for one part, okay, one part of the integrand that is easy to differentiate, because f becomes df by dx. So we look for one part that is easy to differentiate. Okay, so here f goes to df by dx. Okay, so that's one of the parts. And then the other part, we look for the other part that is easy to integrate. Because if we look at the other parts in green, on the left-hand side, we have dg by dx, so the derivative of g. On the right-hand side, we just have g by itself there. So we have integrated g. So we've got dg by dx goes to g. Okay, so this is the idea of integration by parts. We're given some product of functions that we need to integrate. We need to find one part that is easy to differentiate. Okay, so it's very easy to differentiate it between the two parts. One of them will be easier than the other. And then the second part is easy to integrate. Okay, so if we identify these two parts, and then we use this formula over here, then the result will be much easier to integrate afterwards. Okay, because we swap the role of f and g. Okay, so that's the idea here. So let me just put this in a box. Okay, so this is the idea of integration by parts. You've got some problem where a product of two things. We're looking for one part that is easy to differentiate and another part that is easy to integrate. Okay, so let's look at this problem here. We have x times sine of x. I'm sure all of you will agree with me that x is easy to differentiate. Okay, because the derivative of x is just 1. Okay, so we get something a lot simpler by differentiating x. Okay, if we were to integrate x, we would get 1/2 x squared. Okay, right, that's getting more complicated. We want this to become easier to do. So we choose to differentiate x. Okay, and then that just leaves us with sine of x. Okay, which we can then integrate. Okay, so we've got our two parts there. So that's why we call this integration by parts. Okay, because we're splitting it up into two parts there. Okay, is there anyone that doesn't see what I did there? So like, why did I choose x and why I chose sine x? Is everyone okay with that? Okay. Okay, everyone's cool with that. Awesome. Okay, so just looking at this formula here with the f and the g. Okay, that's the standard formula, but it's a bit complicated to remember. The way that we do it instead is by writing it like this. Okay, so it's a bit of a mathematical trick, but if we look at this, we've got dg by dx times dx. Okay, so what we do is we say this dx here cancels with this dx here. Okay, so it's not like fully correct to do that, but it's just something we do to make this a bit simpler. And then this dx here cancels with this dx here. Okay, so if you do that, and we do a little bit of change of variables, we get the integration by parts formula. Okay, so instead of dealing with f and g, we write it a bit simpler as the integral of u dv is equal to uv minus the integral of v du. Okay, so this is what you will see in the notes and in YouTube videos and so on. So instead of writing dg by dx dx, we write it as dv. Okay, so this is the formula that we will be using, okay, in terms of u and v. So let's try and solve this problem of integrating x sine x using this idea of u and dv. Okay, so we have the integral of x sine x dx. Now, same as before, we need to choose something that is easy to differentiate, something that's easy to integrate. So we see here, u becomes du. So u is being differentiated. Okay, so u is being differentiated, and dv becomes v. So v is being integrated. Okay, so this tells us how to make our picks. So we have x sine x dx. We need to pick something to differentiate. We pick x. So this is going to be u. And we need to pick something to integrate. That's going to be the rest of this. Sine x dx, we're going to call that dv. Okay, so it's just a bit of, we're just changing our thinking here. Instead of thinking of it as f and the derivative of g, we think about it in terms of u and dv. Okay, so u is equal to x, and we want to find du. So du is going to be du by dx dx. Remember that from u substitution. So du is going to be dx. That's the first part. Next part, dv is equal to sine x dx. Okay, that's the red part there. We want to find v. So we integrate both sides. Integrate, integrate. The integral of dv is just going to be v. The integral of sine x is going to be minus cos x. Okay. So that's v. So now we have du and we have v, which is the two things we want. So we're going to take these two and substitute it into the right-hand side. Okay. So the integral of x sine x dx is equal to, what's the first thing we need? U times v. U is equal to x. V is equal to minus cos x. Okay, then we have a minus. Then we have to integrate v du. V is minus cos x. And du is dx. So this is going to be minus x cos x plus the integral of cos x dx. Okay, because the minus and the minus, they make a plus. Okay, so finally, we get minus x cos x plus the integral of cos is sine. Okay, and then once everything is done, remember this is an indefinite integral, so we need the plus c. Okay, so that's roughly what the method is. Okay, so we're going to go through tons of examples now. So let's just go over this one more time. So the first thing that we need to do is pick what is going to be u and what is going to be dv. So that is the first thing that we need to do. Remember, u needs to be differentiated and v needs to be, dv needs to be integrated. So dv needs to be integrated. So that's the first thing that we need to do. Pick what u is going to be, pick what dv is going to be. Okay, then the second thing that we need to do is differentiate u, okay, because we started off with u, but we want du. So we differentiate u. We started off with dv, we want v, so we integrate dv. So this gives us the two things that we need. Then we take everything that we found and we substitute that into the right-hand side. So that's going to be uv minus the integral v du. So that's the third thing that we need to do. Okay, substitute everything in. Once that's done, you just do the simple integral. So this over here will be very simple to do. And then remember your plus c. Okay, so 3 steps to this. Choose u and dv. Second step, differentiate u, integrate dv. And third step, substitute everything into the right-hand side and integrate. Okay, so that's the 3 steps for integration by parts. Okay, let's take a look at a few more examples. Okay, so example 2, we have to integrate x e to the x dx. Okay, so same as before. Step 1 is to find what u is and what dv is. So for this example, which of these functions should be u? Any ideas?
X.
X, yeah. So u is going to be x, and dv is going to be the remainder. So it will be e to the x dx. Okay, so that's step 1 done. Well, not done yet. We've done our picks. So now we need to find du and v. So we need to differentiate this first. So du is going to be, the derivative of x is just going to be 1. So it's just going to be dx. Next, we need to integrate this so that we can find v. So v is going to be the integral of e to the x, but that's just e to the x. Okay, so that's step 1 done. Next, we need to substitute into our formula. So remember what the formula was. The integral u dv is equal to uv minus the integral v du. Okay, so let's substitute everything in. So u was x, dv is e to the x dx. That's the integral we want to figure out. U times v, that's that times that, will be x e to the x minus the integral v du. That's these two things over here. So v is e to the x, du is dx. Okay, so it's just substituting in. So now we get the integral of x e to the x dx is equal to x e to the x. The integral of e to the x is just e to the x. So it's minus e to the x. And don't forget to put your plus c. Okay, so same as before. If I just look at the steps here. So that's step 1, step 2, and step 3. Okay, so same 3 steps as we had before. Okay, are there any questions about this example?
So please repeat from step 2.
Okay, sure. So step 2, let me just make a little mark here. Step 2, this was finding du and v. So remember, step 1 was finding u and dv. We need to differentiate the first one and integrate the second. So the derivative of u, we find that. The integral of dv, we find that. Okay, so this gives us du is equal to dx, and v is equal to e to the x. Okay, next we take these two and we substitute that into our formula. So u, this bit gets substituted there, v gets substituted there, and there, and then du gets substituted there. Okay, so I'm just substituting. So you substitute u, you substitute v. So substitute u, substitute v. We substitute v again, and we substitute du. So once you've made the substitution, everything will be in terms of x. So u was x, that's over here. V was e to the x, that's over here. Then we have minus the integral. V was e to the x, we've got that there. And du was dx, we've got that here. Okay. This first part, x e to the x, that just carries down. We're done with that. However, we still need to integrate e to the x dx. But the integral of e to the x is just e to the x. Okay, because remember, the derivative of e to the x is e to the x. That, remember, this had that special property. When you differentiate it, you get the function back. It's the special function that does that. But we can also go the other way around. We can say the integral of e to the x dx is e to the x. Okay, so it goes both ways. The derivative of e to the x is e to the x. The integral of e to the x is also e to the x. Okay, it goes both ways there. So the integral of e to the x dx is just e to the x. But remember the minus sign. So we've got the minus sign there. And then since this is an indefinite integral, you need to add c. Okay, so that's the procedure there. Okay, any questions? Is that good? Okay. Let's take a look at something a little bit more difficult. Okay, so we've got, sorry, we're on number 3. We have the integral of root x, natural log of x, dx. Okay, so again, we've got a product of things. We need to say u is equal to something. We need to say dv is equal to something. Which one of these is easier to differentiate? Or which gives us a simple function after differentiating? Any ideas? Okay, so what is the derivative of the natural log of x? So just as a little aside here, d by dx, natural log of x. What do we get from that? Okay. Check here. One of x. Yeah, that's correct.
One of it. Yeah.
Okay. Okay, so we get 1 over x. So we see that it becomes simpler. If we were to try integrate the natural log of x, that would make it more complicated. The idea is to choose these functions to make it simpler. So we should choose this to be differentiated because we get something simpler. Okay, so natural log of x, that's complicated. 1 over x, that's much simpler. So we choose u to be the natural log of x. So dv is going to be the remainder. So that's going to be x to the 1/2 dx. Okay, so that's step 1, is to do the choosing. Then we need to find du and v. So du is going to be 1 over x dx. We need to find v, so we integrate both sides. So v is equal to, we add 1 to the exponent to make it 3 over 2. Divide, so we get 2 over 3 x to the 3 over 2. Okay, so that's step 2. We find those two things, and then we substitute into the formula. So we have the integral u dv is equal to uv minus the integral v du. We now need to substitute. Okay, so u is the natural log of x. So we have the integral, natural log of x. Dv was root x dx. Okay, so that's this here that we're trying to solve is equal to u times v. So that's going to be 2/3 x to the 3 over 2 times the natural log of x minus the integral of v du. So that's going to be 2/3 x to the 3 over 2 times 1 over x dx. Okay, so I've just done the substitution now. Okay, now we have to integrate. So this is going to be 2/3 x to the 3 over 2 natural log of x minus 2/3 the integral of x to the 3 over 2 times x to the minus 1. Okay, so I've just taken the x to the numerator, so the exponent becomes minus 1 there. So we get 2/3 x to the 3 over 2 natural log of x minus 2/3 the integral of x. 3 over 2 minus 1 is going to be 1 over 2 dx. Okay, good. Now we can just integrate this. So this is going to be 2/3 x to the 3 over 2 natural log of x minus 2/3, and then integrating this, we add 1 to the exponent to make it 3 over 2, divide, so we get 2 over 3, x to the 3 over 2 plus c. So we get 2 over 3, x to the 3 over 2, natural log of x, minus, that's going to give us 4 over 9, x to the 3 over 2 plus c. Okay, and then that was step 3. So you see that after we do the substitution, this remaining integral over here is much easier to solve. Okay, so compared to this, on the left-hand side, we see that this integral in the box is a lot easier to solve. Yeah, and that's the whole idea of integration by parts. We split it up into two parts, the u and the dv, and then we end up with another integral to solve, but this second integral on the right-hand side is much easier. Okay, so the act of splitting it up and then doing it like this means we get something easier to do than what we started with. Okay. We don't have much time for another example, so I think we've done enough of an introduction today. So let me just leave you with some homework questions to do. Okay, same rules as always. I'll give you a bunch to do, and then all of them will be worth 1 extra bonus mark for the, I think, formative quiz coming up. Okay, I'll give you 5. Okay, so that's, you can get up to 5 marks. So we have the integral of x e to the 2x dx. Let's say the integral of x cos 5x. The integral of x squared plus 2x cos x. This one will be worth 2. Okay, it's a bit more challenging, so we'll see if you can do that one. Number 4. Let's do the integral of the natural log of x dx. And I'll give you a hint for this one. Let u be the natural log of x, and let dv be 1 dx. Okay, so imagine there is an invisible 1 over here. Okay, so we're treating it like that. And last one, number 5, this one will also be worth 2 marks. We have the integral of tan inverse of x dx. Okay, and I'll give you a hint for this one as well. Let u be tan inverse of x. Again, imagine there is an imaginary 1 in front. Okay, so this first one, that is 1 bonus mark. That's 1 bonus mark. 1 bonus mark. 1 bonus mark. Okay, because I gave you the hint there, so I can't give you 2. So that's 1, 2, 3, 4, 5, 6. So 6 bonus marks. Okay, so you don't need to do all of them. You can pick one of them to do. But same rules as before. You pick a couple to do. You post them to the WhatsApp group. And if they're correct, then you get your bonus marks. Okay, and you can get up to 6 bonus marks for this homework. So let's just put here, this is our homework problems. Okay. So that's going to be the homework for today. And as always, you have until 5 o'clock to make your submissions for the homework, just so that I can check it and then post the solutions. Okay. Are there any questions about what we've covered today? Okay, so it's not too bad. Sorry?
Can you scroll up? Can you scroll up? I just want to copy the equation.
Okay. Okay, so it's not too bad.
I didn't copy the equation, so I just want to copy.
The page, this page.
Yes.
Okay,
Yeah.
sure. Okay, so it's not too bad. As long as you remember the formula and the 3 steps, you should be able to do all of those problems. So tomorrow we will look at some more difficult problems. Okay, just to increment it a bit. And then on Wednesday, you'll have your formative quiz, so we won't have any lectures then. And then Thursday, we will finish off the integration by parts with a few more examples. And then on Friday, we have a very small section on finding the average value of a function. Okay, so then that will be it for this week. And then that will finish everything for your test too. Okay, so everything up to Friday, that will be in your test too. Okay, and then the following week, Monday and Tuesday, we will have that as test revision. Okay, so we'll do that test revision then, and then you will write on Wednesday, okay, during that tutorial period time. Okay, any questions about the plan for the week? Okay, cool. So then I will see you tomorrow for the rest of integration by parts. Okay, we've got a few more difficult problems to get through. Okay, bye everyone.